Have you ever wondered how multiple tasks can be executed at the same time in a project? Well, that's where concurrent logic comes into play. It's a concept in project management that allows two or more activities to happen simultaneously, much like a well-oiled machine with different parts working together to achieve a common goal. Consider, for instance, the excavation of footings for a building. Once the first set of columns is excavated, the team can start both the excavation of the next set and the forming and reinforcing of the initial set. These actions aren't sequential, they're concurrent, happening in parallel to optimize time and resources. Just imagine the efficiency and productivity that could be harnessed if more tasks were handled this way. It's like having an extra pair of hands or adding more hours to your day. Understanding concurrent logic can significantly improve your project management skills. Let's dive deeper. First, let's understand what we mean by predecessor activities. In the context of project management, a predecessor activity is one that must be completed before the next activities can begin. This is an essential concept in planning and scheduling, as it helps us map out the sequence of tasks and determine the overall timeline of a project. Let's consider an example to illustrate this. Imagine we're overseeing the construction of a building. One of the initial steps involves excavating the site to prepare for the foundation, specifically digging out spaces for the footings columns. These are the solid concrete structures that will support the rest of the building, so it's crucial that they're done right. Now, in our example, we're not just digging one footing column. Instead, we're digging 20 of them. So we'll call this step Excavate 1, 20 footings columns. This is our predecessor activity. The 20 here refers to the number of footings columns we're excavating, not the time it takes to complete the task. Once Excavate 20 footings columns is done, we can move on to the subsequent activities. These might include Excavate 40 footings columns, and form and reinforce 20 footings columns. The first of these involves continuing the excavation work for the next set of footings columns, while the second involves shaping and strengthening the first set of excavated columns. What's important to note here is that these subsequent activities can't start until the predecessor activity is completed. We can't start forming and reinforcing the footings columns until they've been excavated. And we can't start excavating the next set of columns until the first set is done. Every task in a project depends on the tasks that came before it, which is why we call them predecessor activities. So once the predecessor activity is completed, multiple other activities can commence. Let's see how this works in practice. So you've completed your predecessor activity, what next? Well, this is where the magic of concurrent logic comes into play. Let's bring our example back into the spotlight. Remember the excavation of the 1 to 20 footings columns? Now that this task is done, we can move forward. But instead of proceeding with just one task, we can kick off two activities at the same time. Imagine, if you will, a construction site buzzing with activity. The 1 to 20 footings columns have been successfully excavated, and the crew is ready for the next step. But instead of everyone focusing on a single task, the team splits up. One group starts digging into the earth again, beginning the excavation of the 21 to 40 footings columns. Meanwhile, another group starts forming and reinforcing the previously excavated 1 to 20 footings columns. This is concurrent logic in action, and it's a beautiful thing to behold. So why is this happening? Well, the completion of the predecessor activity, which in this case was the excavation of the 1 to 20 footings columns, has opened up two new avenues of work. These are no longer constrained by the need to wait for the predecessor task to finish. They can now run in parallel, simultaneously, hence the term concurrent. Let's delve a bit deeper into this. The excavation of the 21 to 40 footings columns and the forming and reinforcing of the 1 to 20 footings columns are now independent activities. They're like two trains running on separate tracks. They're not competing for resources, they're not waiting for each other to complete. They're moving forward at the same time towards their respective goals. This is the essence of concurrent logic. It's about maximizing efficiency and productivity by allowing multiple tasks to run in parallel once they're no longer dependent on a predecessor. It's about breaking free from the linear, one task at a time approach, and embracing a more dynamic, flexible way of getting things done. It's important to note, however, that concurrent logic isn't about doing everything at once. It's about identifying which tasks can be run concurrently without causing conflicts or resource shortages. It requires careful planning and management to ensure that everything runs smoothly and efficiently. And there you have it. we've taken the concept of concurrent logic and seen it in action on our hypothetical construction site. We've seen how the completion of a predecessor activity can trigger multiple tasks to start running in parallel. We've seen how this can boost efficiency and productivity and keep a project moving forward without unnecessary delays. This is concurrent logic in action. Multiple tasks, once dependent on a predecessor, now running in parallel. And that, my friends, is a powerful tool to have in your project management arsenal. Now, why is concurrent logic so valuable in project management? Let's delve into this. First and foremost, concurrent logic is a key player in time efficiency. When you have multiple tasks or activities that can be executed simultaneously without affecting the overall outcome, you're essentially compressing the project timeline. Imagine a construction project where once the foundation is laid, the team can start building the lower floors even as the upper floors are still being planned. The project isn't just moving forward, it's leapfrogging ahead. The next major benefit is better resource allocation. With concurrent logic, you can employ your resources in a more streamlined manner. Think of it as a relay race. While one team member is running their part, another can prepare for the next stage. It's a continuous loop of productivity that ensures your resources are not lying idle. In addition, there's an increase in productivity. When tasks are performed concurrently, there's a natural boost in the project's momentum. The ball is always rolling, and the project is continuously progressing. This sense of forward motion can also foster a positive work environment, as everyone can see the fruits of their labor sooner, rather than later. Moreover, concurrent logic encourages flexibility. It allows for adjustments to be made without throwing the entire project off track. If one task is running behind, other tasks can still proceed as planned. And let's not forget about risk management. With concurrent logic, project managers can identify potential bottlenecks earlier and take proactive measures to mitigate them. By having a clear overview of all the tasks that are running simultaneously, it's easier to spot where things might go wrong and act accordingly. Finally, concurrent logic promotes better communication. When tasks are dependent on each other, team members are more likely to communicate effectively to ensure the smooth transition from one task to another. So there you have it. Time efficiency, better resource allocation, increased productivity, flexibility, risk management, and improved communication. All these benefits stem from the concurrent logic approach. Clearly, understanding and applying concurrent logic can be a game changer in your project management endeavors. Let's quickly recap what we've learned today. We started off by introducing you to the concept of concurrent logic, a method that allows for multiple activities to take place simultaneously. This is a powerful tool in project management, especially when there are several tasks that need to be accomplished within a certain time frame. We then delved into the role of predecessor activities. These are the tasks that need to be completed before others can begin. Using our example, the excavation of the first 20 footings columns was a predecessor to two other activities, the excavation of the next 20 columns and the forming and reinforcing of the first 20 footing columns. Once the predecessor activity was completed, the other two activities could start, running concurrently. This brought us to see concurrent logic in action. We looked at how, once the first 20 footings columns had been excavated, the next set of tasks could commence. The excavation of the next 20 columns and the forming and reinforcing of the initial 20 both took place at the same time. This is concurrent logic in its essence. Multiple activities happening in parallel, following the completion of a predecessor task. Lastly, we discussed the benefits that concurrent logic brings to the table. It allows for a more efficient use of resources, as multiple tasks can be worked on simultaneously. It also enables a smoother flow of work, as tasks don't need to wait for each other to finish before they can start. This can lead to a significant reduction in the overall project timeline and a more effective project management approach. In conclusion, concurrent logic offers a way to manage multiple tasks at once, in a smooth and efficient manner. It provides a framework for understanding how tasks interrelate and how they can be organized to make the most of available resources. With concurrent logic, you can effectively manage multiple tasks at once, making your project run smoother and more efficiently. That's the power of concurrent logic in project management.